The next is a valence bond theory, which talks about again the formation of a covalent bond, that is how the covalent bond is formed. Before that we did octet rule, but with the octet rule the problem was that the octet rule doesn't explain about the shapes of the molecule or the change in the energy of the molecule. So this limitation, for to remove this limitation, this theory was introduced, that is a valence bond theory. So valence bond theory the mainly talks about the formation of covalent bond, that is how the covalent bonds are formed. So for this we are having a certain postulate. So let's see what are the postulates which are related to this valence bond theory. The postulate number 1. According to valence bond theory, a covalent bond is formed only when the half-filled orbital of two atoms comes closer to each other, or when the half-filled orbital of two atoms overlap with each other. For example, suppose if you want to form a hydrogen molecule, I know that hydrogen molecule which is formed by the combination of two hydrogen atoms. So according to valence bond theory, the atoms doesn't combine. Instead, the atomic orbital of each hydrogen atoms combine. Now, in case of, according to valence bond theory, a bond will form only when the half-filled orbital of the first hydrogen atom will overlap with half-filled orbital of the second hydrogen atom. So hydrogen whose electronic configuration is 1s1, so it have half-filled orbital. So according to valence bond theory, 1s orbitals are spherical in shape. So when half-filled 1s orbital of first hydrogen atom will overlap with the half-filled orbital of second hydrogen atom. But at the same time, the theory also says that a bond will form only when the half-filled orbital, which is containing unpaired electron, the half-filled orbital which is having single electrons, comes closer with the opposite spin. So a bond will form only when these half-filled orbital are having electron with the opposite spin. Because if both the electrons will have a same spin, then ultimately they will repel each other, and due to that repulsion the energy will goes on increasing, and instead of getting a stability, instability will goes on increasing. So these two orbitals will overlap only when the orbitals are having an electron with the opposite spin. So according to the valence bond theory, finally they will come closer and they will overlap, and this is the electron of the first hydrogen, this is the electron of the second hydrogen. Since the orbitals are having electron with the opposite spin, so ultimately they will nullify each other effects, and hence their repulsion will decrease, the repulsion between them will decrease. Now according to the valence bond theory, the orbitals which are getting closer to for the overlapping, these orbitals should have approximately same energy, or I can say comparable energy. If the difference between the energy is very high, then in that case the overlapping will not take place. The next postulate that during the overlapping what happened is, suppose if this is nucleus of these orbitals, then during the overlapping between the nucleus the number of electrons increases. Here the electron density has increased between the nucleus, and if electron density has been increased, then ultimately due to that the repulsion between the nucleus will decrease and the attraction will increase. Attraction will increase, that means this nucleus will attract this electron, this nucleus will also attract the electron. So ultimately I can say that here the repulsion between the nucleus has decreases and the attraction has increased. But keep in mind that nucleus are not attracting, ultimately the nucleus attract this and this nucleus attract this. And if the attraction increases, that means the more energy will evolve, and hence I can say the molecule will become stable. Then the next is a covalent bond is always formed. A covalent bond is always formed at an equilibrium distance. That means the distance between, at equilibrium distance means when the force of attraction is equal to the force of repulsion. When these two atoms are getting closer to each other, when two atoms comes closer to each other, there are the two forces acting on it. The number one, the attractive forces, and the number two, that is the repulsive forces. Now attractive forces are because of the attraction between the nucleus of the one atom and the electrons of the second, or I can say the nucleus of second atom and the electrons of first atom. There is a attractive forces, but at the same time there is a repulsive forces also. Repulsive forces will be the nucleus of the first atom, the nucleus of the second atom, same charges, and the electron of the first atom, the electron of the second atom will have same charge again, so repulsion. So covalent bond is formed only at a point or at a distance when attractive forces are equal to the repulsive forces, and that point is called as a equilibrium state. So bond is always formed at equilibrium distance. And the strength of a bond, the bond which is forming between the two atoms, the strength of a bond depends upon the extent of overlapping. More the overlapping, more stronger the bond will be. Lesser the overlapping, lesser will be the bond strength. But again, at the same time, the overlapping goes on increasing till the equilibrium distance is achieved. Once the equilibrium state is, or equilibrium distance is achieved, beyond that the overlapping decreases the strength of a bond. So strength of a bond depends upon the extent of overlapping till the equilibrium distance. The number of bond formed by an atom. How many bond an atom will form according to valence bond theory totally depends upon and how many half-filled orbitals are present in an atom. If an atom is having only one half-filled orbital, it will form a single bond. If an atom is having two half-filled orbital, it will form double bond. That is a two bond. If half-filled orbital is having three half-filled orbital, then it will form three bond. For example, suppose I'm considering lithium molecule. The lithium whose configuration is 1s2 2s1. So it have only one half-filled. This is from the inner shell. From outermost shell, it have only one half-filled orbital, so it will form single bond. Beryllium, or if I am considering nitrogen atom, nitrogen whose atomic number is 7, 1s2, 2s2, 2p3 will be the configuration. Outermost shell, it is 2s2 and 2p3. So ultimately here I can say there is a three half-filled orbitals. So nitrogen, according to valence bond theory, since the nitrogen have three half-filled orbitals, so it will form three bond. And valence bond theory also talks about the shapes of a molecule. According to valence bond theory, a shape of a molecule is decided by the orientation of the atoms or orientation of orbital during the overlapping. During the overlapping, the direction in which the orbital overlap, the bond also form in the same direction and the shape is decided by the same orientation. So here the valence bond theory which talks about the formation of a covalent bond, how it is formed. And according to valence bond theory, during the bond formation, the main involvement is of atomic orbital, and that to have unpaired electron, that is a half-filled orbital. So according to valence bond theory, the electrons which are getting closer, they should have opposite spin, because if they have same spin, ultimately the bond is going to be if they have a same spin, then these electrons are going to repel each other, and if the electrons are repelling each other, that means the bond will not form. Then number of bond formed by an atom is equal to the number of half-filled orbital. The geometry of a molecule is decided by the orientation of the orbital during the overlapping. So now let's see, on the basis of valence bond theory, let's see the potential energy diagram for hydrogen molecule. How the potential energy of the atoms changes when the two hydrogen atoms comes closer for the bond formation. For H2 molecule, this graph is of energy versus internuclear distance. So here we are ultimately going to see that how the energy changes when the distance between the two atomic orbital changes. Here the energy is 0, that is origin I can say. So the graph is something like this. So the graph is something like this. Suppose this is the case where the internuclear distance between the two atomic orbital is very large. The internuclear distance, it goes on decreasing. So here these are the two orbitals having the opposite spin. The electrons have opposite spin, but at the same time I can say the internuclear distance is very large. That means these two atoms are not interacting with each other. So there is a no attraction or repulsion between them. And if there is a no attraction or repulsion between them, then energy related to this is going to be approximately 0. But as I'm moving toward the left hand side, it means I can say that the molecules or the orbitals are getting closer and closer. So suppose I'm talking about the point, at this point, the orbitals are more closer. So if the orbitals are getting closer, you can see that the energy goes on decreasing. Energy decreases. The reason because attraction is increasing. So as the orbitals are attracting each other, the certain amount of energy evolved, and due to which I can say that energy decreases. Let I'm talking about this point. At this point, orbitals are more closer. So here, so more energy is evolved. So again, the energy has decreased. Let's see at this point. That means still again it decreases the distance between the two orbitals. So here at this point, just the overlapping has started. At this point. That means here. Orbitals are properly overlapping. Now, if I'm moving beyond this point, that is beyond this point, I can say that here the energy goes on increasing. That means here this will be the point. Beyond this point, if you are bringing the atomic orbital more closer, then energy increases. And if the energy increases, that means the atomic orbitals are starting repelling to each other. That means if atomic orbitals are getting more closer to this distance, if the distance between the nucleus is less than this, here this value for the hydrogen is 74 picometer. So if you are reducing the distance between the nucleus of this orbital less than 74, then energy goes on increasing. And if the energy increases, that means the nucleus are getting more closer, so that the repulsion between them increases and the attraction decreases. From here, this point to this point, I can say that attraction was more than repulsion. At this point, the attraction is balanced by the repulsion. So this point is the equilibrium distance. But if you are getting the atomic orbital more closer, so if atomic orbitals are being more closer, then in that case the nucleus comes more closer to each other, and due to which I can say the repulsion increases. And once the repulsion increases, that means the energy will also goes on increasing. So as the valence bond theory says that the bond is formed at equilibrium distance where attractive forces and repulsive forces balance each other. So I can say that in the hydrogen molecules, a bond between the two hydrogen atom will form when the internuclear distance is 74 picometer. And that's why in case of H2 molecule, we always say that the hydrogen-hydrogen bond length is 74 picometer. Now, during the attraction or during the overlapping, the certain amount of energy has been evolved. So how much amount of energy has been evolved? So it depends upon this energy graph. When we measure this value is 436 minus 436, that is below 0. Minus 436 means so much amount of energy is evolved. So if you want to break this bond, suppose during the bond formation so much amount of energy was evolved. So if you want to break this bond, then ultimately I will say that supply so much amount of energy, the bond will break, and that's why this is called as bond enthalpy of H2 molecule or hydrogen-hydrogen bond. So this is about the diagram when the orbitals were having the opposite spin. Now let's see what happens when the orbitals getting closer having same spin. If two orbitals having same spin, then what happens? So we have two orbitals, two atomic orbitals, half-filled atomic orbitals which are getting closer with the same spin. So here you can see with the graph that as the orbitals are getting closer, that means as I'm moving on the left hand side, that means the internuclear distance decreases. Internuclear distance decreases means orbitals are getting more and more closer. And if the orbitals are getting closer, due to same spin, they repel each other, and due to the repulsion, you can see that energy goes on rising. And if the energy increases, then instead of stability, instability increases. And if instability increases, then there is no chance of the bond formation, and hence the bond will not form. And that's why the valence bond theory says that a bond will form only if the two orbital having opposite spin. If the atomic orbital with the same spin comes closer to each other, they will not overlap because the energy goes on increasing. That is, the stability goes on decreasing. So this is about the valence bond theory, and this is about how the energy changes when atomic orbitals are getting closer and closer. The next we are having the types of overlapping. In this part actually we are going to learn about the different types of overlapping, and again this is based on the valence bond theory only. So in this chapter actually in 12th standard we are considering only the S overlapping of S orbital and P orbital. So if I am considering S and P orbital, then how many types of overlap we will have? So here I can say that the first atom S orbital will overlap with the second atom S orbital. Then I can say the first atom, the p orbital of the first atom may overlap with the second p orbital of second atom. Then similarly, I can say that s orbital of first atom will overlap with the p orbitals of the second atom. So here we have total 3 types of overlapping, that is SS overlap, PP overlap, and SP overlap. So let's start with the first one, that is SS overlap. Now what is SS overlap? The SS overlap, it is a overlapping in which the s orbital of the first atom with the half-filled orbitals overlap with the s orbital of the other atom, half-filled s orbital of other atom with the opposite spin. Means in a definition you have to consider all the conditions which was given in the valence bond theory. So you have to consider the half-filled orbital of both the s orbital. The s orbital electrons should have opposite spin, as well as their energy should be approximately same. So I can say SS overlap, it is defined as overlap in which half-filled s orbital of the first atom overlap with the half-filled s orbital of the second atom with the opposite spin of the electron and the comparable energy of the orbitals. So here the example for SS overlap, so that is a molecule in which the SS overlapping takes place is hydrogen molecule. So hydrogen molecule where the SS overlapping takes place. So to understand hydrogen molecule, let's talk about the hydrogen atoms from which H2 molecule is formed. So hydrogen atom whose atomic number is 1, its electronic configuration is going to be 1s1. So I can say that it is having a single electron in the outermost orbit. There is only one orbital at that to have single electron, that is half-filled orbital. According to valence bond theory, a bond formed by number of bond formed by an atom is equal to the number of half-filled orbitals. So it is having a single electron. So I can say the first hydrogen atom, from first hydrogen atom, s orbital will come. We all know that s orbital is spherical in shape. So first hydrogen atom, then second, with opposite spin, comes closer to each other. Both have 1s orbital. So 1s orbital of the first hydrogen atom, 1s orbital of the second hydrogen atom. Both overlap, and so that we get overlapping, that is the sharing area. So overlap, so both electron comes closer, and finally we get H2 molecule. So this is H2 molecule where the 2 hydrogen atoms are overlapping, and hence I can say the bond formed between the hydrogen atom is a covalent bond, and this is considered as a sigma bond. Whenever the s orbital overlap, it forms sigma bond. We have 2 types of covalent bond, one is called sigma and the other is called pi bond. When the overlapping takes place on axis, it is called sigma, and when it takes place on laterally, then it is called pi. About the sigma and pi bond, we are going to learn in a detail after once this types of overlapping is over. So just for a time being, it is a sigma bond. So this is SS overlapping, where half-filled s orbital of the first atom overlap with the half-filled s orbital of the other atom with the opposite spin and the comparable energy. The second example which we have is, the second type which we have is PP overlap. So PP overlap or PP overlapping, I can say. The PP overlapping, where the p orbital of the half-filled p orbital of the one atom overlap with the half-filled p orbital of the other atom with opposite spin. The example, I can say the formation of fluorine molecule. Fluorine molecule formation. Now fluorine, whose atomic number is 9, so its electronic configuration is 1s2, 2s2 to p5, have 5 electron in the outermost orbit. We all know that electron only present in outermost orbit takes part in a bonding. So 2s2, 2s will have 2 electron, and to p5 here we have. First all will fill singly and then pairing will take place. So I can say that in 2p5, this is for 3 orbital in P, Px, this is Py and Pz. And here the s orbital is completely filled. So which electron will take part in a bonding? Then I can simply say the electron which is present in a orbital which is half filled. So only this Pz orbital will take part in a bonding, the other orbital will not take part in a bonding. So from fluorine molecule only Pz, that is only p orbital will come, but out of p orbital only Pz will take part in a bonding. We all know that p orbitals are having a dumbbell shell. So dumbbell shape structure, that is this is the first p orbital of fluorine molecule. Let this is Px, that is a orbital which is oriented on x-axis. This is Py oriented on y-axis, and this is Pz oriented on z-axis. I can say that here Px is having a pair of electron. So this is having pair of electron, Py also have pair of electron, only Pz is having half filled orbital. So here the Pz will only take part in a bonding. Then overlap with another fluorine atom. This is the first fluorine half filled orbital of first fluorine atom. Again, this is x-axis, this is y-axis, and this is z-axis. Here, the second, now this Px will have pair of electron, Py pair of electron, and Pz have only one electron, and that too opposite spin. Then only the overlapping will take place. Now, both will overlap. And once they overlap, that means a covalent bond will form. So let's see the overlapping of both the orbitals. So we have these two other orbitals. So here the Px, pair of electron. So since they have the pair of electrons, so not taking in a bond part in a bond formation. Only the Pz orbitals half filled, so they takes part in a bonding, and so the first fluorine and second fluorine. The p orbital from the first fluorine, p orbital from the second fluorine. So ultimately I can say fluorine molecule is formed. So this is F2 molecule. This is the fluorine atom. The first fluorine atom, this is second fluorine atom. And here again between the two fluorine atom a single bond is formed because only a pair of electron is taking part in a bonding. Fluorine have only one half filled orbital, so it can form a single bond. And the bond here form is nothing but sigma bond. Okay, so after the PP overlap, the third is SP overlap. SP overlap, the example where one s orbital of the one atom overlap with the p orbital of the other atom. The example I can say HF molecule. Now from these two example I can say from the hydrogen the s orbital will come and from the fluorine p orbitals will come, and so that overlapping will takes place. The condition is same, hydrogen is having one s orbital, the fluorine is having pz orbital. So I'm just directly showing the overlapping. From hydrogen, 1s orbital will come, which is a spherical in shape. So this is from hydrogen with one electron, 1s orbital of hydrogen atom. Overlap with p orbital. From fluorine whole p orbital will come, but only the bonding only, or in overlapping only the pz orbital will takes part. Okay, now in this case here, During the overlapping, the opposite side gets smaller in size. Now question arises, what is the reason that during overlapping the opposite lobes get smaller in size or get reduced? Simple reason, this lobe is nothing, these two lobes are not the different, it is nothing but the single lobe. So during the overlapping, what happened, some amount of energy is released, and the amount of energy released decide the stability of a molecule. So during the bond formation, every atom tries to release more and more amount of energy, because if it releases more energy, the stability will more as well as the bond will be stronger. So during the overlapping, what happened? So this orbital, the whole amount of energy will get concentrated on this side. So whole energy get concentrated on the overlapping side, and that's the reason that opposite side gets smaller in size, because the whole energy is getting concentrated or it moves to the overlapping side, so that more amount of energy should be evolved and the stability should be achieved. Now this is hydrogen and fluorine. From fluorine again, as I said, p orbital will come. First floor, this is x-axis, y-axis, and this is z. That is px, py, and pz. Px is having a pair of electron, py also have a pair of electron, and pz have one half-filled orbital, that is unpaired electron. So now again they will also overlap. So during the overlapping, again during overlapping, the whole energy will get concentrated on one side, so that opposite side gets smaller. Okay, and here the hydrogen will come and hydrogen will overlap, and this overlapping, that is a bond will form, and this is px and py. So I can say that this is HF molecule. Now in case of HF molecule, again the bond which is formed between the hydrogen and fluorine is a sigma bond, because again during the bond formation the s orbital has involved in the overlapping, and whenever the s orbital is involved in overlapping is always a sigma bond. And second thing, that the overlapping is taking place on the axis. Here also the overlapping was on the axis, that's why the bond was sigma. So in HF molecule also the bond form is sigma bond. So this is HF, that is this is sp overlapping. So ultimately here we have three types of overlapping SS, that is s orbital, and s orbital is overlap. pp, that is p orbital of one atom and p orbital of other atom is overlapping, and then sp overlapping, that is s orbital of first hydrogen and p orbital of the other hydrogen, and p orbital of fluorine atom is overlapping. So these are the three types of overlapping.